Right now, sitting in your room, everything feels perfectly still, but you, your chair, and the building you're in are currently hurtling eastward at 1,670 kilometers per hour. The reason you aren't thrown against the wall is perfect synchronization. The bedrock beneath you, the oceans, and the atmosphere are all locked together, moving at the exact same velocity. But suppose that synchronization breaks. Suppose the Earth's bedrock suddenly stops spinning for exactly 1 single second. The destruction stems from the instantaneous, violent failure of a physical system that has been perfectly synchronized for eons. At T0, the ground locks in place, but the laws of physics dictate that the momentum of everything resting on top of that ground does not. This animated diagram shows exactly how that momentum transfers. The sudden halt of the bedrock instantly ejects unattached objects eastward at 465 meters per second, easily breaking the sound barrier. Inside a normal room, this translates into immediate chaos. Your furniture, your appliances, and you become high-speed horizontal projectiles, slamming into the nearest eastern wall. Outside, the scale of destruction multiplies. Cars, trains, and pedestrians are launched in a simultaneous eastward spray, colliding with anything rooted deep enough to survive the initial stop. An earthquake shakes the tectonic plates and destabilizes foundations. This is a ballistic event that weaponizes every single thing that isn't bolted directly to the Earth's crust. By half a second in, a new threat emerges. The Earth's atmosphere did not stop with the ground. You have billions of tons of air still retaining its original momentum, now dragging across a suddenly stationary bedrock at supersonic speeds. This creates a dense wall of wind that acts like a planetary-scale grinder. It flattens entire forests in milliseconds and strips concrete and steel straight off the frames of any surviving structures. The very air required to keep us alive has transformed into a physical weapon, aggressively erasing whatever debris the initial ejection left behind. At 0.8 seconds, we hit the heaviest unattached element on the planet. Trillions of tons of ocean water still carry their full rotational momentum. This cross-section shows the resulting fluid dynamics. Entire ocean basins slosh eastward at over 800 kilometers per hour, compressing into towering deep-water waves as they collide with shallow coastal shelves. These 20-meter megatsunamis have a specific target. This photograph of Mumbai shows the exact type of dense, low-lying coastal infrastructure sitting directly in the path of that water. And the math applies universally across the globe. Vertical economic hubs built right on the water's edge, like New York City, face the exact same immediate annihilation. The hydrosphere operates as a massive, sweeping reset mechanism. It mathematically guarantees the drowning of our most vital, heavily populated coastal centers. Then, at exactly 1.0 seconds, the pause ends. The Earth instantaneously resumes its original rotational speed of 1,670 kilometers per hour. This triggers a reversed velocity mismatch. All that displaced water, air, and debris is now violently jerked a second time as the bedrock suddenly accelerates beneath them. The timeline is cruel. Any structure weakened by the initial stop must now endure an immediate, high-velocity jerk in the opposite direction, guaranteeing total structural annihilation. The physical shaking stops permanently after that single second, yet the deadliest phase has just begun. Modern utility grids fail in a rapid cascade. Shattered power stations cause immediate global blackouts, which instantly paralyze water purification plants and pumping stations. Logistics collapse next. Hospitals run out of generator fuel within hours, and the global supply chains delivering food and life-saving medicine are permanently severed. The collapse is systemic. When every interdependent lifeline is severed at once, the sheer scale of the disruption makes recovery impossible. This raises a final geographical question. Did anyone, anywhere, survive the initial impact? We have to look away from the equator and focus on the extreme northern and southern latitudes. Rotational velocity drops to near zero at the poles. As this South Pole marker suggests, these completely isolated, frozen regions escape the primary physical destruction truck to stop and restart. The wreckage doesn't just sit there. Shattered refineries and leveled forests trigger globe-spanning fires. The resulting plume of soot and pulverized concrete is vast enough to choke the atmosphere, reflecting sunlight back into space and plunging the planet into a multi-year nuclear winter. Human progress relies entirely on an uninterrupted, perfectly balanced planetary equilibrium. A single second of pause is all it takes to erase hundreds of years of civilization.